Welcome back to the Grand Solar Minimum channel. Tonight we have a very special guest joining us tonight. He's the discoverer of the triggers of the ENSO variability. Ladies and gentlemen, Per Strandberg. How you doing tonight?
Oh, fine. Thank you for having me.
Well, thanks for joining us. We try to find people throughout the community who have such knowledge as yourself, and if anything, we want this channel to be the foundation of most people's education when it comes to the Grand Solar Minimum and what revolves around it. I was looking at your website, coolingnews.com, and first of all, I want to say the excellent work that you've done there. But the first paragraph of this here, it says cooling news. The sun is currently entering as what is called a grand solar minima. The current solar cycle is 24, and the coming solar cycle 25 that will follow are both set to be very weak and will only display few sunspots or possibility of none at all. However, the current climate research establishment, those who the media and the politicians trust, who are only looking for human causes of climate change, have gone to great lengths to try to convince the public and other scientists that changes in indirect solar activity are of no importance to the Earth's climate. They claim that the solar part of recent warming is too small to have an important influence because the variation, the heat output reaching the Earth, is too small to have any measurable impact, and that indirect changes of the solar activity has no effect at all on Earth's climate. Now, when I read this, and this is probably the best way to put it when people are new to this topic, and you broke it down really well, but are they even listening to themselves when they say these things? To have that statement to even be published, that the sun has nothing to do with Earth's climate at all?
Well, they look at what is called the TSI. That means the total solar irradiance, and that's the amount of heat streaming down towards Earth. And that's the variation of that is very small. So they look like during there was a warming period between 1980 and 2000. And they said it can't be the sun because it's, they just look at the heat transfer. So they thought the global warming theory with anthropogenic global warming is fit bills, so to say. And that's what they look. And then they, because, all the money is going into research for the greenhouse gas theory. It's multiplied, and the Fed is believe that it is the changes in carbon dioxide which drive climate change. So, but then the warming stopped. But then there was a big momentum behind it. Theory, so it just continue.
I'm looking at you talked about theories of global warming, and your first theory, which is the generally accepted one, is that the release of greenhouse gases from burning of fossil fuel and from land use is responsible for the recent temperature increase. And here recently, President Trump has cut spending to NASA for their carbon dioxide monitoring program that supposedly is contributing to the warming, but in fact NASA has reported that greening is the main effect from the CO2. So we know right there we're starting to see the truth is slowly but surely revealing itself through the data, and I feel like people like you and others who are your message is getting through finally, I guess is what I'm trying to say.
Yes. Yeah, for one thing, there are no evidence that changes in carbon dioxide is an important driver of climate change. And I listed this. First of all, there are no fingerprints from carbon dioxide from real measurements that show that carbon dioxide is an important driver. You can look at the missing hotspot in the tropics. The scientists, the research, the physics about climate, they claim that the East Coast should be warm warming in the higher 30,000 feet above the tropics. And this is called a tropical hotspot, but it's not there. And second, the theory is that a small increase in carbon dioxide is going to warm the oceans, and that should release more water vapor, and that in return should warm the world. If you look at, they have had satellites that cover the outgoing radiation, and during El Niño period there is more heat in the oceans and the atmosphere. And what's happening is that the temperatures follow the black body radiation theory, called Stefan Boltzmann law. And when the temperatures goes up, the radiation goes up according to this law. But if there would be more greenhouse coverage from more water vapor, which is the most important greenhouse gas, then this increase should be lower. But they haven't found it. So just there you can say that there's no evidence that carbon dioxide is an important driver of the global warming. And secondly, you have the warming follow this electromagnetic variation of the sun. And somehow they believe that this stopped in the last century. But we know that in the 20th century solar activity was high. That explained much of the warming we have been seeing. Secondly, you have the problem with the climate models. They show more warming that's really happening. And if you look at people, they become very convinced of this theory because these people use supercomputers and very advanced calculations. But the problem is to forecast climate change, you need to include all factors, and they don't do that. It's like if you compare, if you hire a lot of bunch of economists, and you say that they want you want them to build economic models for the stock exchange in Dow, for example, for the year 2100, and we know that economic changes goes in cycles, and then you can say that they can forecast the stock exchange value 100 years in the future, but nobody would believe them.
Right.
But if you are a builder of a plane, military, civilian airplane, and you instead of using wind tunnels, you have a supercomputer, and you build a model of this plane and want to look at the feature of the plane in different speed and so on. You use a supercomputer, and it's very, very effective. So the climate models is coming somewhere in between these two extremes.
I wanted to talk a little bit about the ENSO work that you've done, that you've come up with two ways of figuring this out here, as far as the two main drivers are, of course, the El Niño Southern Oscillation, and the second one is also variations in solar activity. What led you to this kind of work, and how long have you been doing this kind of work?
I have been doing it for a very long time. I started actually 10 years ago with this first website. My background is I have a degree in applied physics, so I follow the data, and I think I'm a person I think outside the box, so to say. So I'm not limited to what other people are doing. I do my own things. So I started in 2011. I have a website on climate forcing. I figured that the sun and electromagnetic variation of the sun and the Henrik Svensmark's theory, I was looking into that, and I wanted to see if I could find some carbon dioxide forcing. So I put together a neural network model and look up all the available data I could find, and then I tried to see if I could have some correlation between ENSO and the global temperature from satellite measurements. And I got some good result, but then I got the idea I should just look at one factor at a time. So then I figured I knew that ENSO and global temperature was related, so I set that to 100%. And then I went through all the factors. And if you go to this website, you can see I have actually the global temperature percentage value is over 100%. It's SST is called, and it's 110%. And then I went down, and I saw that after that I got the variation of Earth's rotation. We call it length of day. Sometimes the Earth is rotate 1 millisecond faster, and sometimes it's 1 millisecond slower. And that actually is an indication from ENSO. So it's called LOD. And that's related to ENSO.
Okay.
After that, you have had sudden oscillation is of course the same as ENSO. And I noticed that the solar wind speeds and so on. So I found different solar factors. Wind speed, and magnetic variation, but I didn't find the galactic cosmic ray had some influence on this. What I measured was the delta T temperature, variation in temperature each month. So because it's like AC/DC.
Right.
If you look at DC values, it's difficult because I can't put temperature to zero. Of course, there's a Kelvin you can do that, but there are no stable temperature on the Earth. It's vary all the time. So I look at variation. That's important. So I didn't find any effect from the sense galactic cosmic rays. Just found small changes from sunspots and so on. So from there I figured that the sun has an important influence on temperature. And from there, if you go to the man down there, this Professor Cuccioli, Vincent, he's a Frenchman, but he speak very good English, and he pointed me to this idea that variation in Earth's rotation has something to do with temperature. From there, I thought it must be variation in the lunar gravitation, tidal effect. So I looked for lunar data, lunar cycles. And I found a software I could print out the position of the moon and the sun. And I actually have been working with this for a long time. I just finished a few days ago. I have now much better data.
Yeah, interesting enough, reading about your work involved with tidal pulses and solar activity. This was a similar conversation that we had with David Dilley, and I think his studies was a lot stronger on the moon, as here we're more on solar activity. But and also a part of the whole ENSO, you also developed something called and I was wondering if maybe you could kind of talk to us a little bit about that and how you came up with that idea and its effectiveness towards your work.
Yeah, I actually 2 years ago I was invited by Niels Axel Murner. They had a conference in London, so I went there and presented my result. Unfortunately, some of my result is I had a bug in my software, so it's not 100% accurate. But anyway, I presented my work and how I used neural network to come up with my results. And before that, I presented my result. Actually, I went down to Copenhagen and on the tour. I'm a member of a skeptical group in Norway. So we went down to Copenhagen by boat, and I presented my result there. And that time I didn't have this error, but the result, I think I have data on another web page from that. It was very good to be able to present my work to other people.
Now, I read a little bit about this, and you were showing about the results that you got. It talks about SST 110%, ENSO 100%, LOD 68%, solar wind was at 49%. Are these all the factors that go into the results of your work? Like this is
no, this is separate. I
Okay.
just started with this and identified that the sun, electromagnetic variation of the sun is a main factor. And then I went on further I calculated the position of the moon and the sun during perigee, the time when the moon is closest to the Earth. And I tested if I using a neural network, if I got a better result or worse result, and I modified it so I could minimize the error as much as possible. And and then I put these two factors together: the moon's effect, the tidal effect actually, and solar effect on ENSO. First I tried to use a feedback mechanism, and I got statistically a good result, but it was not good enough to do reliable prediction. But then when I went to I was at a presentation in London, I had much better result, but actually it was a bug in the software whom I got 2 good results.
Oh.
So, but you can see it is still quite good, I think, from the last ENSO maximum, and also now we should go up in getting some higher ENSO result. But I'm not confident that the result is good enough yet. So I will try a different avenue to improve this with different techniques. But what I can state is that the lunar cycles and the electromagnetic variation of the sun is the main weak driver of changes in all these indices that are used in climate research. Because you can think of it that you have a lot of random noise, white noise, and then you have a weak forcing, which is systematic, but the noise is not systematic. So after time you get the weak forcing, which is going to dominate what's happening. And the problem with all the climate models, all the people, they think that they can make a good model because they have advanced thermodynamic models and supercomputer and all this. But they forget the weak forcing from outside. There are extraterrestrial forcing, which these are the dominant forcing or the climate, but they just ignore it because it's outside the boxes or the comfort zone. They have no knowledge of how to work with these factors, I think.
Well, you're right about this is out of their comfort zone, and I think 2018, there's been a lot of things that's happened I've seen in mainstream that's starting to talk about cooling instead of warming. And, you know, I'm sure you saw the headline where Trump had cut the funding away from NASA for the CO2 monitoring program. And, you know, and the biggest thing that I hear from the liberals is that Trump is ignoring science, when that's exactly the opposite of what Trump is doing. He's listening to the science. That's why he's cutting the funding to such programs. And, you know, when NASA reported that its main effect was greening and not warming, I mean, it's just common sense for the administration to take the actions that they did take and, you know, start cutting some of these funding. And that's, you know, your website talks about all about the money. And here at the Grand Solar Minimum, I kind of drive that as well. The only reason why these people are so desperate to make the public and other scientists believe that we're warming and not cooling is because for so many years the science that we've been fed has not been correct. It's been manipulated to fit their agenda so that grant money continues to roll in. But I'm starting to see a change in that, and I think the United States is definitely, hopefully people will follow that lead and pull out of that Paris Treaty as well, because we saw what was in store for the United States, and basically that treaty wanted us to carry that $100 billion bill by 2020. So I just wanted to get your thoughts about what do you think about politics and climate, and why should either have anything to do with each other, if at all?
It's an important factor. I look at there's going to be election in Sweden in the autumn here. And I listen to the politician. I live in Norway, but I'm Swedish, so I follow both politics in both countries. And almost every politician in Scandinavia are climate fanatics.
Right.
Tell us this is the existential threat and all these stupid things. And, it's terrible. But yeah, I don't know if Trump is good in science, but he's sure better than the previous president. I think he's no more.
I think we all agree with that statement there.
Yeah. So it's the hope. How long it will last, I don't know. But actually, early 2001, I saw a program about Henrik Svensmak's theory. I thought that was worked better as a theory. I don't think his theory is the dominant factor for climate change, but the sun's variation is. I have a different theory to everybody else, I think. You want to hear?
I do.
Actually, if you look at from outside, most of the heat is just beaming down to the warm part of the equator and the surrounding area. And then you have the Arctic or even the Antarctic, but the Antarctic is more isolated. And it's like a chimney, or a window. You open it up and all the heat is going out. If you close the window in the room, it's going to warm. So you have a flux from the tropical up to the polar region. And because recently I talked a lot about the polar vortex, but actually it's the polar jet stream. When they disturbed, you have things like it's a sudden warming.
Sudden atmospheric warming. Yeah, the anomaly that happened.
Yeah, and then you break up the Arctic jet stream, and you have cool air streaming down into the land masses, Eurasia, North America, and so on.
Yeah, that's
cooled down the ground, and a lot of heat is going up into the atmosphere and escaping Earth. And when you have change in the jet stream, you get more cloud formation in the temperate area of the world, and that you get less heat penetrating these areas. And you get a gradual cooling from these events, and that's is driven by pressure waves in the atmosphere. So for example, you have tidal pulses or your electromagnetic variation, and the changes the circulation, and you get more wavy jet streams. Now today, of course, you have the alarmist scientists that say that it's melting Arctic is causing jet stream variation.
Yeah.
Totally false. But,
they want you to believe that this sudden atmospheric warming anomaly, and that's what it was, is anomaly. They want you to believe that it was melting all the ice in the Arctic, but like you said, it indeed pushes cooler air into the part of, like, for instance, the northeast and eastern part of the United States is why they saw some of the cold records that got shattered this year. But it kills me.
And the cold makes all the heat from the ground to disappear into the space.
Right. We can't forget that.
And I think those changes are more important than variation in galactic cosmic rays variation. That's my theory.
Well, we definitely, I think, the more I've learned about cosmic ray, and this is relatively new research. It's not been around very long, and I think that's what a lot in the scientific community were rejecting in the beginning. But now I think the science is showing the proof in our skies right now, the cloud coverage, the satellite images that we see anyway, how much cloud coverage that we have, and we all know, or we're learning now, that increased cosmic rays cause seeding of our atmosphere, creating more cloud nucleation, and stuff that I learned about by watching Heinrich Svensmark, the Cloud Project. So
yeah, I listened to when we went to Copenhagen. I listened to he had a lecture, and he looked at cosmic rays effect on climate on long terms. So for example, right now we're in an ice age period, and we have a lot of cosmic rays, and when we don't have it, it doesn't have it. We have warmer climate, and that may be true because what one should look at is the temperature in the oceans and not so much in the atmosphere.
Right.
The long term is in the oceans because its heat capacity of the ocean is enormous. And it takes time to change. Even small changes take time to change that temperature.
Yeah, I saw something that 95% is, as far as temperature goes, 95% of it is ocean and 5% is atmosphere. So, but like I said, this is stuff that, a lot of this research is new. So myself and Mari and a lot of us at the Grand Solar Minimum channel are discovering this new research. But what I've noticed in 2018 is it seems like the drum beat's getting a little bit louder for this cooling that's happening. And I saw on Sky News that there was a gentleman that actually talked about how forecasters are now saying that expect little ice age conditions for the next few decades. And I would have never imagined or even thought of hearing a news organization uttering those words to the public. So
I mean, news organizations don't care about what's real or not real. They care about this is how many viewers they get.
Right.
So the headlines, if they think that the headlines is causing more people to look at the news than they use it. And of course, the last decades is all about global warming, and all people are convinced. A lot of people, at least, are convinced that the Arctic are melting and so on. But actually, as you know, the Arctic is going through a 60-year temperature cycle.
Yes.
About 60 cycles. And I have some data here. If you go to put in Google historic Greenland temperature data, and then you look at image.
You said historic temp in Greenland?
Yeah. Historic Greenland temperature data. And then you click on image. It's very easy to do. Then you look at the temperature graph you get from different stations in Greenland, and you see that it was warm in the 1930s and 1940s.
Okay, yeah.
And everybody can do it. And the problem is that people are not aware that where they can go and look at data. This is raw data. It's not manipulated by GIS, Goddard Institute of Space Studies.
Yeah, I think a lot of it too is like this stuff right here. When we talk about cycles, you're basically referring to here is in the 1980s, we were looking at a temperature drop, and since then we had the rise. Well, now it's that time in the cycle for that drop, and basically that's just putting what you're saying is you just have to connect the dots, and these graphs are here for that.
I mean, you should look at the real data and not manipulated data, and then you see that's what's happening in normal. It's nothing unusual at the moment. Of course, the solar activity is dropping, and
like a rock.
I put up some points here, and it's even worse in I had a link to what's happening in Iceland, and the Icelandic Meteorological Office asked why the graph was changed by Goddard Institute of Space Studies.
Right.
And just shook the head.
So I guess my next question for you is, where do you stand on the debate? I've heard people say that the Grand Solar Minimum starts at solar cycle 25. there's actually some scientists and other people who have an opinion that the grand solar minimum will actually not happen until after 2030 because some think that we're going to have another maximum. I know that cycle 24 was the weakest in the last 150 years, and they're predicting solar cycle 25 to be even weaker. I'm just curious, just opinion, where do you see the timeline beginning for the actual grand solar minimum?
As I see the grand solar minimum started with solar cycle 24. I mean, this cycle is weaker than the previous.
I agree.
What's will happening in 25, I don't know. But when we have weak solar cycles like we have now, those cycles are longer. So I think Mike's expecting that the solar minimum will happen in 2021, a few years from now. And actually, when I was starting looking into this, it was in 2006, I think. And I found out about this man, Theodor Landscheid. I think you know about him. He was a German who was interested in predicting. He predicted Maunder-like solar decline in the coming decades. So I have here, if you go to abrupt climate change action.
Okay.
There you have a frequency analysis of cycles. One is 22 year, one is 52,
bottom,
80.
yeah.
And you can see the solar activity goes in cycles. And it's a Fourier transform calculation, I think. Somebody had made. And then you can go down next. You can see that after 2000 there is a weak cycle. Actually, here it shows that the cycle 25 is actually larger than 24. But you have to wait and see. And under there you can see what's called the barycentric movement of the sun. You have heard about it? Or? Barycentric movement of the sun. So solar movement. Actually, the sun is not at the center of the solar system. Time is moved around like gravitation. It's pushed by the big.
Is that what these images are? That you have down at the bottom where it has the wolf and the square?
You see Dalton and next. And wow. You can see here, normally the sun is moving in small circles, but during solar inactivity, these circles are disturbed because of Uranus and Neptune disturbing, so the sun is going to get hanged in a smaller loops. And but actually there was a lot of discussion about this when I started looking at this. But actually that's and they say that the sun is just like a falling body in the space, so it shouldn't have an effect on the sun.
That's interesting.
But that would be true if the sun was solid, or if the sun was, let's say, the same size as Earth, which is, I mean, the sun is huge. To demonstrate this, if you think of a sphere around the planet Earth, as we share the same size as the sun, then if you go by a spacecraft to the moon, then you only get halfway out to the sphere. So you can imagine how big the sun is. And actually you get different differential torque forces. Like we know that the rotation at the equator is larger than at the poles. And there exists science called helioseismology, which the scientists look at the Doppler effect of the light coming from the sun. And if you have a sunspot on the other side of the sun, they send out vibrations when the explosion occurs, so you can get to look at the sun's interior, if a woman has a baby in the stomach, you can look at with the ultrasound. It's a similar technique, and 70% down to the Earth's center, the plasma, the gas, is almost like a solid. So the rotation is the same below that level. So you have a very loose plasma at the sun's surface, but when you get in more towards the center, the pressure is increasing, and the gas becomes denser and denser. And somewhere there is called the tuckle line. Somewhere down there you have a friction, and because of these movements, that's what I think. What I think is a little bit controversial, but what you get there is that the solar activity is determined by these forces. And then if you go back and look at solar activity and the temperature, it follows cycles. You have solar minimum. The last solar minimum was Dalton minimum, and before that Maunder minimum, and Spörer minimum, and Wolf minimum. And these minimum follow these solar cycles. At the conference I was in London, there was a man I call, his name is Nicolas Cafetta, and he had looked at this, and because the sun is tilted 6 degrees,
right?
This has also effect on solar activity. And this man, the Landscheid, he used something called Bernoulli series. You can have series on one different series, statistical series. So he expect this solar minimum to be like a Mondenman type minimum. So maybe he's right. I don't know, but you have to wait and see.
That's kind of what, and when we first started our research, we do the best that we can to report on the grand solar minimum and news that's related to it. But when we first started this research, at first, we were kind of optimistic and thought maybe that we were looking at a Dalton type minimum. But the deeper we dig, the more and more we see similarities to a Maunder minimum type situation coming up. I know I heard somewhere that they're forecasting, as of this June through April of next year, they're forecasting almost 0 sunspots. So I'm going to be paying extra close attention to that. A friend of mine over in the UK, David, happened to mention today that there are no sunspots on the Earth-facing side or the far side at this point. So maybe this is that part of the forecast that they might be correct about. Who knows? I've heard so much about solar cycle 25, but the one thing I have heard that seems to be a common is that there is going to be an unknown factor to this solar cycle. But for me, I think it's going to be a factor that's going to accelerate the cooling, just because we've been told that, even if we're in a grand solar minimum, so many people have said this, that we're only going to experiencing enough cooling to take us down 0.03 degrees Celsius on that global anomaly temp thing. And so far, since February of 2016, we've already dropped off around 0.67 degrees Celsius since February of 2016. So we're already well past that threshold that global warmists have told us that we're not going to see any more cooling past a certain amount. This not even being the official beginning to the solar minimum as well. That's what concerns me. That's why I believe that things are accelerating a bit faster than some are forecasting.
And this scientist you interviewed in from Newcastle, Russian, Zarkova, no?
Yes, Zarkova.
Yeah, I think it's important. And what you can see in the solar activity is that the different north and solar south part of the sun is not in phase.
Right.
And also you have to remember that the temperature cycle in the Arctic is going to go down the next decade, because and that's it's apart from solar activity. I think it's more towards solar lunar cycles. So they have an additional cooling effect there.
Wow.
But yeah, you have to see and wait. But I think it's also important to not be too alarmed about. You don't want to fall in the same trap as the global warming that's telling us
that's true.
End of the world.
That's true. Right? And you know, here at this channel, we try to be as neutral as possible. Mm-hmm. We want the truth to get out, but I think our overall message, and people like you as well, is that if this is something that we've lived through in the past, it's something that man can get through once again. We're already discussed. The reason why this channel exists is because if we start the discussion now, then maybe we'll take action sooner than we need to. That way, when we start to see challenges with our crops, we
adapt, I think.
Right, and I think already we're starting to see places. I saw a development in Africa where the vertical growing is becoming a big deal now, and so I think there's just too many things that mankind and technology. I'm pretty sure we're going to find ways to adapt and thrive through this challenging period, and that's what it's going to be, as a challenging period. But you're right, you have to be careful on how you relate this information. You don't want to come off as a fear monger, but more of a informationalist or educator.
Right. I think that's important. One day I decided to look into this more closely, because I looked at BBC on their web page every day or second day. There was something about global warming, and I really realized it just was brainwashing. It's propaganda, nothing else. So I remember there was some gold frogs in Costa Rica was just disappearing because of global warming. Wait a minute, I think. First of all, in the tropics, the temperature doesn't vary very much.
Right. No, it doesn't.
So but I wonder why they claim that it was dying off because of global warming. It turned out it was a fungus, but anyway. So I started looking at the sun, and I looked both sides, and I realized that this is not true. It's global warming.
Right.
So what I found a very effective method was looking at graphs and data. And I put in a question, and then I look at images. And from there I could find interesting scientific papers. It's a very good method to find your way through all the propaganda. I think what few people realize is it is not about global warming only. It's about natural history,
right?
Natural sciences. You have a type of people interested who have been brainwashed that people are destroying the planet. It's like if you're going to be a priest, you're not Buddhist or Hindu or something. Same religious belief as all the others. And that's true for this type of academic research. You have the same type of people attracted to study this subject. And also, when they start to study, if they don't do the line, they are kicked out of the institutions.
Right.
They don't get any funding. It's very. But what I actually was upset me most was what I realized when I looked at it, how big this was.
Yeah.
the politicization
Yes.
around it. You know, this can maybe sounds like a conspiracy, but all this hysteria, the science changed from being climate mainly driven by the sun. Now suddenly it was greenhouse gases, human-caused greenhouse gases.
Right.
And that transition happened only during a few years. You know, it was through the UN mainly. We have had James Hansen in a congressional hearing it was in 1988. I don't know if you have seen. He presented this theory to all the Congress people in Washington. The first chair of the IPCC, he was a Swedish professor in meteorology, and he knew the Swedish Prime Minister. The Swedish Prime Minister, he had once or twice a week, he exercised by playing tennis. And he had his professor as his sparring partner. So I think that they talked a lot about global warming. He thought it was a very good idea to scare people with.
Right.
And then Margaret Thatcher, she found this theory and thought it was good to stop the coal miners.
Right.
But behind this is the big banking families like Rockefeller.
Yes.
And they pour money and incredible amount of money to form not only NGOs like World Wildlife Fund and things like that, but also all the pressure groups. I mean, they look very spontaneous, and we have a real problem because you have people who called activists, and they convinced that this is existential problem. You can't talk to them, you know. They're convinced that a religious belief.
Yeah, and what's shocking about that? You talk about activists. I now see on our website here, Craigslist, they're actually advertising jobs for college students, and the headline is "Help Fight Global Warming." And you talk about brainwashing. They're hiring these kids out of college, and they want to teach these kids that this is what we're doing to our climate, man-made global warming, and they want people to just go out there and spread this all out. And I guess what upsets me the most is we were talking about CO2 and the increased levels, and the medieval times when I believe, correct me if I'm wrong, but I believe somewhere around the 270 ppm on CO2. Now, that was the hottest time that our planet has seen, supposedly, was the medieval warm period. But if you use the data from the CO2 from then and comparing it to now, where we're at 411 ppm, shouldn't we be boiling? If we were supposed to assume that was the cause of heating, according to these people, we should be boiling past what we were in the medieval times, and we're not.
Yeah, and what you're saying is not true. I mean, we know that from measurement right now that when we have a strong El Niño, we get about the level increased by about 3 ppm per million. But when we have after La Niña, it's only 1. And if you go back, there are some studies that show that the level of carbon dioxide during the late medieval warm period was about 400 from fossilized leaves. You have this opening of how they're breathing carbon dioxide and put out oxygen and water vapor. Stomata is called. Right. And some studies show that it's about 400 ppm at that time, and that level continued 2 years after the end of the medieval warm period. So you can't trust the ice core data because it's very the bubble is not safe from diffusing these gases. You should question the data, I think. But of course, the level of carbon dioxide follows temperature, because when the sea surface gets warmer, they release more carbon gases like carbon dioxide. When it is cooler, they absorb more carbon dioxide from the atmosphere. So there are a lot of things that they don't tell us.
True.
What I found when I researched it is that wherever you look, you find things that's not true, or they admit to present this data to the people. For example, you have this when they stopped exploding atomic bombs in the atmosphere in 1963.
Right.
The level of radioactive carbon-14 in the atmosphere was 5-6 times higher than normal. But after 5 years, it was just half. That means that the carbon dioxide you exhale now, about more than half of it after 10 years is absorbed in the ground, in the plants or in the sea. They claim that increases from fossil fuel. The claim is look at the issue between carbon 12 and 13. Much of the carbon dioxide you get from the ocean come from underwater volcanoes. So they haven't looked at this. They say that there's a difference and it must be from fossil fuel. And of course, some of it comes from fossil fuel, but if you look at how much of the carbon dioxide comes from burning of fossil fuels, is about 3%. The rest are natural, or it can be from cutting down forests or things like that. So its additional effect from humans are small, but they don't tell you that or explain it for you.
And
also the greenhouse effect from carbon dioxide is estimated to be about 4% of the total greenhouse effect. So if you double that, and also the effect from carbon dioxide is almost saturated. So if you increase the level of carbon dioxide, the greenhouse effect from it should be very small.
And I also heard that with the amount of nitrogen or atmosphere plus coming out of our bedrock allows our plant life to absorb more CO2. So, there goes that theory as well when it comes to your greenhouse gas warmings and all that.
And the sea level rise now is constant. It's the same as it was about 100 years ago.
Right.
And the temperature in the tropic earlier is very stable. Yet say that the poor countries will suffer most by greenhouse gas increase.
Good
point. Temperature increase is small, so it should not affect any plant life or animal life in the tropics. If you have global warming, you get warming in the temperate region, and it's mostly beneficial, I would say.
Right. No, I agree.
The problem is also, like, when these climate scientists, I don't think that there are any climate scientists. I think there are people who are atmospheric scientists or computer geeks, or,
I agree.
It's theories, but there are none or very few real climate scientists who grasp all these different disciplines.
Well, there are people out there who call themselves climate scientists, and then I watch them also tell the public that the Arctic is melting at a fast pace. And then you go to NASA and you look at the Arctic sea ice extent, and you've seen that there's actually growth. What we see right now, there's nothing to be for an alarm. In areas that might have lost some ice, there's also areas in the Arctic that gained ice. So, and not just the extent, but the thickness as well. Well, it's been a pleasure having you on, and I hope we can do this again. Before I let you go, I was wanting to know if there was anything that you would like to emphasize as far as part of your message, part of your work.
Yeah, would like to emphasize that the main drivers, as I see it, at least, is from of course Milankovitch cycles, but long term, but also
Right.
electromagnetic activity of the sun, and also influence from lunar cycles, not so much from carbon dioxide.
Not at all. Not at all. I think everybody that watches this channel can agree with those two statements, lunar and solar activity. Like I said, we had a conversation with David Dilley, and he repeated the same thing. So, but again, it's been a pleasure having you on our show.
We should not be worried about global warming.
No, not at all.
Right. Okay.
Well, sir, we appreciate you once again for coming on. I appreciate the work that you do. I will be following you a lot closer now that I've had the time to get to know you a little bit. We're also going to direct people to your website from our website. I can't thank you enough, though.
Yeah. Thank you for having me.
All right. Well, thank you for joining in tonight with our interview, and we'll talk soon. All right. Take care.